Morning guys, so we're going to go through the A2 revision sheet that I put together. This is going to be a little bit of a long video and hopefully I'll get all the way through it without any interruptions, just so I'm only putting one video up. Like I said, I'd have a go at these questions and then listen through, check your answers, make sure you're doing okay with it. Any questions, any topics in particular that come up that you need a bit of help with, just let me know. Okay, so if we start with the first one, we've got an integration question where you've got two things being multiplied together. So that makes question one an integration by parts question. Just remember when you're setting everything up that you're using correct notation and you're not skipping any steps. You want things to be as clear as possible. So remember, integration by parts, one of your terms is labelled as u, the other as dv by dx. The term you label as u is the term you're going to be differentiating, and you want that to make things simpler. So ideally you want a term that when you differentiate it disappears or just becomes a constant, which are nice and easy to deal with. So I've labelled u as my x term. Okay, so if I differentiate x, I get 1, which is nice and easy to deal with. If you integrate, and I've missed a 2, it's a good start. Okay, I've got sine 2x. If I'm going to integrate sine 2x, I get minus cos 2x. And then don't forget the extra factor of 2 that you've got there has to go on the bottom, since when you're integrating you divide by that extra factor. So I get a half cos 2x. Right, and then our integral becomes uv, so we've got minus a half x cos 2x minus the integral of v du dx, which is just minus a half cos 2x. Okay, and at the minute we've still got our limits. Right, so the start of this isn't going to change. I'm going to leave that exactly as it's written. Now, two minuses are going to become a plus, so I'm going to put that plus together. Ignore the half for a second. If we integrate cos 2x, I'm going to get sine 2x. And again, that factor of 2 needs to go on the bottom. So that would be a half sine 2x. Now, if I put the other half back in, I get a half times a half. So I get a quarter sine 2x between pi by 2 and 0. And all you're going to do is chuck in pi by 2 and 0 into the whole thing. If you chuck pi by 2 into all of this, this one is just going to come out as pi by 4. This is going to come out as 0. And then if you chuck 0 in, that one's going to be 0. And that one's going to be 0. So your answer is just pi by 4. Okay, if we look at the second question. So question 2, we're looking at this one. So we've got I is 16 minus 16 lots of 0.5 to the power of t. We want to differentiate it and find the value when t equals 3. Okay, so what we've got is we've got something in the form a to the power of x. Now when you differentiate a to the x, you get a to the x ln a. Okay, so that's one key fact you need to remember. And this does often come up as a show that question. Show that the differential of this is this. So if you can't remember how to do that, I'd look back in your textbook or go back through the notes that we've made and make sure that you can remember those steps. There's not that many. They're not massively difficult steps. It's just remembering how to do it. Okay, so if I differentiate this, di by dt, any constant when you differentiate is just going to disappear. The minus 16 is just a multiple, so I'm going to leave that at the front for now. And then I've got my a to the power of x term. I end up with a to the x ln a. So I end up with 0.5 to the power of t ln of 0.5. Now, first thing I'm going to do, just because it's easier to see what's actually happening, is I'm going to rewrite it as a half instead of 0.5. And you'll see why in a second. So we're now going to find the value of this when t equals 3. Now, if you just plug t equals 3 in and chuck it in a calculator, your calculator is going to give you a decimal. So this is something you're going to have to do without your calculator. Okay, so I get minus 16 lots of a half to the power of 3 ln of a half. Now, a half cubed is going to give you an eighth, and an eighth of 16 is 2. So I've got minus 2 ln, and then a half, because we want this to be a whole number instead, we're going to use our power rules from GCSE, and we're going to say this is 2 to the power of minus 1. Okay, that means you've got two options. You could bring the minus 1 down and deal with it, or take the minus 2 up. I showed you the other way last lesson, so I'm going to show you this one this time. All we're going to do is, we know the power rule in logs is that the number in front I can bring up as a power. So I can say this is ln 2 to the minus 1 to the power of minus 2. Okay, and we know powers inside and outside a bracket, you're going to multiply. So I get ln of 2 squared. I just end up with ln 4. Okay, and that's all they're looking for, something in the form ln a. Right, if we look at question 3, sorry, lost my questions, there we are. Right, we're doing a partial fractions question. So again, pause the video, have a go at the question, and then we'll go through it together. So to start with, we've got part A is 5 over x minus 1 and 3x plus 2 that we are going to split into partial fractions. So first thing we're going to do is, I'm going to write this as a over x minus 1 plus b over 3x plus 2. That means to give all three of these fractions the same denominator, the a fraction needs the 3x plus 2 bracket, and the b term needs the x minus 1 bracket. Then we test when x equals 1, I'd get 5 equals 5a, this will just become 0, in which case a equals 1. And when x equals minus 2 thirds, you get 5 equals, this one's going to disappear, and this one becomes minus 2 thirds, take away another 1 is minus 5 thirds b. And so if you divide by minus 5 thirds, b is going to equal minus 3. So you can actually write your answer as 1 over x minus 1 minus 3 over 3x plus 2. Okay, part B is, what they want us to do is they want us to integrate 5 over x minus 1 3x plus 2. We've just shown that this can be written like this, so I'm going to actually integrate 1 over x minus 1 minus 3 over 3x plus 2. This is much easier to integrate, so our integral becomes this one. Remember, whenever you've got a fraction, if the top is the differential of the bottom, then you've just got logs. Okay, so if I differentiate this, I get 1, which is what I've got on the top, so I've just got ln of x minus 1. On the second one, if I differentiate 3x plus 2, I just get 3, which is the top, so I just get minus ln of 3x plus 2. I don't need any multiples in there anywhere, because I get exactly what I need. And then I've got plus c. Now the first thing to do is, if all your terms are in terms of logs, what you can do is we can say let c equal ln k. That way we can turn all of this just into one log term. So I get ln of x minus 1 minus ln of 3x plus 2 plus ln k. So remembering your log laws, when you're adding terms together, you just multiply them. So I get ln of k multiplied by x minus 1. And then when you're subtracting, you divide by it. So divided by 3x plus 2. And that's it. I get one entire term. Okay, and it's quite often that you're going to be tidying up to that standard. All right, and then part C of this question. Part C is to find the particular solution. Sorry, I think I'm on a bit of an angle there. Find the particular solution to this equation. So I've got x minus 1, and you should see that some of these terms look familiar. 3x plus 2 dy by dx equals 5y. Now, whenever you're solving a differential equation, it's the one where you're separating out variables. Okay, so what we want to do is we want to get all the x terms on one side, all the y terms on the other. Okay, and then you'll find what you've just done before is quite familiar. Now, what I'm going to do is I'm going to divide by y to put that on this side, only the y, because remember, if you look back to our other question, you'll see why I leave the 5 there. And then I'm going to divide by all of this to put it on the other side. So I end up with 1 over y, and I'm leaving the dy there, equals, and then I get 5 over the 2 brackets, so x minus 1, 3x plus 2, and I'm also bringing the dx up. So I've now got all the x terms on one side, all the y terms on the other, and I can integrate both sides. So if I integrate 1 over y, when you differentiate y, you get 1, so it's just ln of the bottom. And on this side, we've actually already integrated this. This was our answer to b, which we said was ln of k brackets x minus 1 over 3x plus 2. Okay, now the reason that we made this into just one entire log term is because if I've got log of something equals log of something, then this term here must be equal to this term here. So you can basically just remove the logs from both sides. So y is equal to k lots of x minus 1 over 3x plus 2. And the last part of this is they gave us 2 values. They wanted the solution when y equals 8, x equals 2. So we're going to plug that back into here to actually find out what our constant k is. So I get 8 is equal to k times, well, 2 minus 1 is 1, over, and then 3 times 2 is 6, plus 2 is 8. So all I need to do is multiply it by 8. I get k is 64. So actually, my particular solution to this is that y is equal to 64 lots of x minus 1 over 3x plus 2. And that's it. I've got my particular solution. Right, if we move on to question 4. So question 4 is a binomial theorems question. Okay, quite a lot to it. We're going to expand up to x cubed to begin with. Then we're going to use this fraction and our coefficients of x and x squared to find the value of a and b. So if we do the expansion first, so you've got 2 minus 3x, it's a pair of minus 2. Now remember, you are given the formula in the formula booklet, but the first thing you need to do is to manipulate your equation because it has to be in the form 1 plus x to the n. The n term can be as complicated as possible, but the key fact is it has to start with a 1. So if I'm going to make this into a 1, I'm dividing by 2. So I'm taking that factor of 2 outside, the power goes with it, so 2 to the minus 2. This then becomes 1, this one then becomes 3 over 2. So 2 to the power of minus 2 is 1 over 2 squared, so I get a quarter of 1 minus 3 over 2x to the power of minus 2. So I've got everything in the format that I need. As I said, formula is given for you, so it's 1 plus nx, n minus 1x squared, and then n okay, but that is given in the formula booklet for you. So we're going to apply that to our term. So we're going to leave the factor of a quarter outside. I've got 1 plus minus 2 times, and my x term, and this is where people keep going wrong, the x term is everything that you've got there. So your x term is actually minus 3 over 2x. Okay, and then you've got minus 2, minus 3. Again, your x term is all of that. And then I might have written a little bit big. And just about fit it on there. Okay, so you can type this straight into a calculator. Just ignore the x's when you type it in. And obviously remember that this term is still squared when you type it in the calculator. This one's still cubed when you type it in a calculator. So I've got a quarter of 1 plus 3x plus 27 quarters x squared plus 27 over 2x cubed. Okay, and last bit you need to do is we just need to multiply all the way through by a quarter to get our final result. So I get a quarter, 3/4 of x, 27/16 x squared, and 27/8 x cubed. So you've got all of your terms from expanding your binomial. Right, the second part of this is that f of x was equal to a plus bx over 2 minus 3x squared. Okay, which obviously we can rewrite as a plus bx times by 2 minus 3x to the minus 2, which this is what we've already just expanded. So we're essentially working with the equation a plus bx multiplied by and your answer that you've just worked out to part A. Okay, so it tells you the coefficient of x is 0 and the coefficient of x squared is 9/16. So those are the two facts that we're given in the question. Now you can, if you want to, expand all of this by multiplying all the way through here by a, all the way through by bx, and then combining terms together. There's nothing wrong with that. It just might take you a little bit longer. If we actually look at it as we want to look at the x terms first of all. So by multiplying these brackets out, the only terms that are going to give me a single x value in there is if I multiply a constant out of this one by an x term. So I know those two multiplied together are going to give me an x value. So I get 3/4 times a. Okay. I also know if I do bx times by a quarter, that's going to also give me an x value. So I've got plus a quarter b. And I know that whatever that is, it should give me 0 because it told me the coefficient of x is 0. And we're going to tidy that up a little bit. If I multiply all the way through by 4, I get 3a plus 1b equals 0. There's one equation. Pretty sure at this point you can guess we're going to end up with some sort of simultaneous equation. Right, if we look at the second one, we want to look at our x squared terms. Okay, now the way to get an x squared term is if I multiply an x term by an x term. So I've got 3/4 b. Or I've got a constant times by an x squared term. So I've got 27/16 a. And this time it tells us the coefficient. So the answer it should give us is 9/16. Okay, so all we want to do there is if I multiply all the way through by 16, I'd get 12b plus 27a equals 9. And I've got a second equation. And you're back to linear equations from GCSE that we can solve quite easily. So all I'm going to do is, to get these to have the same values, I'm going to multiply this one by 12 so that the b's are the same. So I get 36a plus 12b equals 0. And then on this one, I had 27a and 12b equaled 9. So I can do top row subtract bottom. I'm left with 9a equals minus 9, in which case a equals minus 1. And then I'm going to plug that back into this equation. So if a is minus 1, I get minus 3 plus b equals 0, in which case b equals 3. And that's it. I've got my a and my b value. All right. Last part of this wants us to find the coefficient of x cubed in this expansion. So if we look at this, first of all, to create the x cubed term, what you're going to do is the x cubed term is going to be if you take a constant multiplied by an x cubed term. So for x cubed, we're going to do 27/8 times a, or I could do an x term times by an x squared term. So I've got 27/16 times b, and that's going to give me my coefficient of x cubed. All we're going to do now is actually plug in what we worked out a and b to equal. So we said a was -1, so I've got 27/8 times -1. And we said b was 3, so 27/16 times 3. And if you chuck that into a calculator, you're going to get your coefficient of x cubed as just 27/16. Right, if we look at the next question. So, question 5. Sorry, awful lot of pieces of paper. Question 5, we are looking at parametric equations. So you're going to find the equation of a normal at the point where t equals 3, and then we're going to find a Cartesian equation. Right, so first things first, x is equal to ln t and y equals t squared minus 2. So if you're going to find the equation of the normal, two things we need is we need the gradient, so we're going to end up differentiating, and we need the actual coordinate. Now the coordinate is nice and easy to find before we start. If t equals 3, you get x is just ln 3 and y is 3 squared minus 2, so I get 7, which means the coordinate I'm using is ln 3 and 7. So that part, nice and straightforward. Second part is we are differentiating. So what we're going to do is we're going to find dx by dt. So if I differentiate ln t, I get 1 over t, and we're going to find dy by dt. So if I differentiate t squared minus 2, I just get 2t. That means my dy by dx term is that I need to do my dy term divided by my dx term. So I've got 2t divided by 1 over t. Now remember, when you divide by a fraction, you flip the fraction upside down and multiply. I actually end up with 2t squared. We then need to find that at the point where t equals 3. So I get dy by dx is equal to 2 lots of 3 squared. I get 18. But remember, dy by dx gives you your gradient of your tangent. So the gradient of the normal is then minus 1/18. Okay, so I've got my gradient and I've got my coordinate from earlier. I'm just going to rewrite those so that they're both on the screen. Right, so if I'm going to find the equation of a line, all I need to do is chuck that into y minus y1 equals m brackets x minus x1. Okay, now normally that will get you the majority of your marks, and usually they will ask you to simplify this question or simplify any sort of equation that's given like this. So we're going to multiply all the way through by 18. I get 18y minus 126 is equal to minus x plus ln 3, and then we're just going to bring these two terms across so that I've got an equation where everything's on one side and it's equal to 0. So I get x plus 18y minus 126 minus ln 3 equals 0. There's the equation of my normal. Alright, so if you've forgotten parametric equations, I'd go back through the chapter on parametrics. And then part B of this question, remember we wanted the Cartesian equation. So I've got x was ln t and y was t squared minus 2. Remember, a Cartesian equation is you just want an equation that's only got x's and y's in. So all we're going to do is we basically want to eliminate t. So if I rearrange this equation to say t equals, all I'm going to do is take e of both sides. So I get t is equal to e to the power of x. That means I can substitute that into the equation. So I get y equals e to the x all squared minus 2. So I actually end up with multiplying powers inside and outside, e to the power of 2x minus 2. There's my Cartesian equation. hopefully nice and straightforward for the Cartesian. Right, next one we're going to look at is question 6. So this is a bit of the trapezium rule, and then I think I'm zoomed in a little bit too much there. Okay, we've got a bit of a trapezium rule and then a bit of integration by substitution, which is worth quite a few marks. So hopefully trapezium rule is nice and straightforward, and again the formula is given in the formula booklet for how to answer that one. So first thing we're going to do is, if we're going to complete this table of values, and I'm just going to write this on the sheet, all we're going to do is you're going to chuck your x value into your equation for y. So if you put 3 in there and type this into your calculator. So I've got 1 over I end up to 4 decimal places with 0.1847, and then I'm going to do the same, but we're going to plug in 5 instead of 3. Okay, and you're going to end up with 1/6 or 0.1667. Okay, so trapezium rule is given in the formula booklet, and it is basically that you do a half h times your first y value, 2 lots of any middle y values, plus your last y value. So in our case, h, remember, is just the difference between your x terms each time, because that's how wide your trapezium is. So the difference each time is 1. So in our case, we're going to do a half of 1. And just remember, this is approximation this time rather than equals. Okay, so I've got half of 1 times by your first y value is 0.2. The middle ones that you have are 0.1847 and 0.1745. And then your last term is 0.1667. And you're going to chuck that into a calculator. You're going to get a result of 0.543 to 3 decimal places. Okay, so that's the approximate integral between 5 and 2. Next part is a little bit trickier and worth a lot more marks. What you're going to do is you're going to use the substitution x equals u minus 4 squared plus 1 in the integral. Let's just write that down. Okay, so what we're aiming to do, remember, integration by substitution. I'm just going to zoom out again. Integration by substitution is just that you want to replace any x term in here with something in terms of u. Okay, so you can substitute all of this into there and tidy it all up, or I'd advise rearranging just to see what it gives us if we rearrange for u. So if you subtract 1 from both sides, and then if we square root, and if we add 4, so you can see everything on the bottom of my fraction there is just going to be replaced with u. So that part, nice and easy to deal with. The dx, a little bit trickier. You're going to have to differentiate your x term. What I would recommend is, because this is just a squared term, you can, if you want, use chain rule. That's absolutely fine. Or you can just expand your brackets. This is a normal standard quadratic from GCSE, which would make it easier to differentiate. So you got u squared minus 8u. You would get plus 16 plus the extra 1 there. So I get plus 17. That is something that is much easier to differentiate. So u squared becomes 2u, 8u becomes 8, and 17 disappears. So I can say that dx is equal to 2u minus 8 du. So I've now got everything that I need to replace in terms of the x's. Last bit I need to do is just remember, if you're turning everything into u's, you need your limits to change as well. So because we rearranged here, to get what u is equal to. I'm just going to draw them in a box here. So when x equals 5, u becomes 4 plus 5 minus 1 square rooted. So 5 minus 1 is 4, square root of 4 is 2, 4 add 2, I get u equals 6. When x equals 2, 2 minus 1 is 1, square root of 1 is still 1, 4 add 1 is 5, so I get u equals 5. So that means I've now got absolutely everything that was originally an x, I can now replace with a u. So I get the integral, instead of 5 it's going to be 6, instead of 2 it's going to be 5. This whole thing we said is just going to become 1 over u, because all of this we said was equal to u, and dx we're replacing with 2u minus 8 du, which means it's already looking much simpler to deal with. So first things first, dealing with something like this, it's not one of our ones that's going to come out as logs, because if you, not as it is anyway, because if you differentiate u, you get 1, and I've still got a u on the top, so I'm not going to go straight for logs. Instead, because it's only a single term on the bottom, I can split it into 2 separate fractions. Which are both nice and easy to deal with. This u just disappears, so I'm actually just got 2 minus 8 over u. Now, if I integrate 2, I get 2u. And if you differentiate u, you get 1. I want 8, so I want 8 lots of ln u. And we're integrating between 6 and 5. Just be very careful in these questions, because there's a lot of manipulating terms to get to a point of integrating. It is quite common for people to get to this point and think they've already integrated. So just make sure you're consistent with writing down your notation to know that you haven't actually integrated yet. That's why you've still got your integral sign. Okay. Now that we've integrated, we're just going to chuck in 6 and 5. They do want the exact solution. So again, you're going to avoid using your calculator. So 2 times 6 is 12. Minus 8 ln 6 minus 2 times 5 is 10 and 8 ln 5. So what I actually end up with is 12 subtract 10. Actually, if I write it all out just so that you don't get lost on any of the minuses. Okay, be careful there, you've got 2 minuses, so that does become a plus. In which case 12 subtract 10 is 2, and you've got 8 ln 5 minus 8 ln 6. Now, because the multiples are the same on both, I can just leave it as an 8 outside. And when you're subtracting, we write it as a division. Okay, so just be very, very careful manipulating your logs. But that's it. That's our exact value for the integral of our equation. Right, so that was as far as we got before. So these ones are all new ones. So for question 7, if I just put that on the screen so that you can see, we're going to turn 7 cos x minus 24 sin x into this format. We're then going to write down the minimum value, and then we're going to solve when that equals 10 to 2 decimal places. So 7 cos x minus 24 sin x in the form of cos x plus. Okay, so first thing to remember, okay, is that this sort of format is our cos of a plus b. It is given in the formula booklet. If you can't remember it, as always, I would recommend as much as you can to know your formulas. It just makes everything that bit quicker and that bit easier to spot when it comes to solving proof questions. Okay, now I will do this with a highlighter because I know some people have struggled with this in the past. All you're doing is matching up coefficients on both sides. So if I look at the coefficients that are going to work for cos x. So the cos x on this side just has a 7. Cos x on this side means that that 7 has to be created from r cos alpha. Okay, if I do the same with the sines, now these should always match. Okay, so the negative doesn't actually have any effect. The sin x on this side has to match the sin x on this side, in which case 24 has to be r sine alpha. So 2 things you need to do. To work out alpha, if I do the sine term divided by the cos term, I'd get tan alpha. The r's would just cancel each other out, equals 24/7. And so alpha is tan to the -1 of 24/7. And just remember, it did say between 0 and 2 pi, so you should be in radians. We get how many decimal places? 3 decimal places, 1.287 radians. Okay, second part, and we've been through all the proof on this to work out why we do what we do for r, but all you need to remember is it's Pythagoras, so it's the square root of 24 squared add 7 squared, which I'm pretty sure is 25. Yeah, it's one of our Pythagorean triples. Okay, and so you can write your equation as 25 cos of x plus 1.287. Okay, and so that's our first one. Right, part B is then, hence write down the minimum value of this. Well, our minimum value, remember, cos of anything, it doesn't matter what's in here, cos will only ever go between 1 as a maximum and -1 as its minimum. So minimum value would be if cos of everything equaled -1. So 25 times -1, minimum value is -25. Okay, it will always just be a 1 mark question for state the minimum or maximum. Okay, because it doesn't take a huge amount of work to do. Right, part C is solve 7 cos x minus 24 sine x equals 10. So we've just said that this can be written as 25 cos of x plus 1.287. And we're solving between 0 and 2 pi. So because we've said we can write it like this, first thing I'm going to do is divide by 25. (10 divided by 25, you're just going to get 2/5. In which case, if you take cos to the -1 of 2/5, we're working at 2 decimal places, so 1.16. In fact, if we don't quite round just yet, 1.1 to make that 59. Okay, so we need to find the other values in our region. Don't forget, you're going to extend your region by 1.287 just because we're not just working with x, we're working with x plus 1.287. Now, it's up to you if you use the CAS diagram or if you use the cos graph. I'm going to stick with the cos graph. I'll let you do the CAS diagram. Okay, so if I've got one value there, remember this height here should be 2/5, really badly designed 2/5 there. But I've got one value there, and potentially one value there depending on how it comes out. So that one's 1.159. Remember, if you're using the graph, the symmetry is from the center of the curve. So I've got from that point, that direction and that direction. So I've got pi by 2, pi, 3 pi by 2, and 2 pi, and then that one's obviously 5 pi by 2. So we're going to do 2 pi plus our value and 2 pi minus our value. I'm going to get another value at 7.442 and another value, that was wrong, at 5.124. all I need to do then to find my x value is I'm just going to subtract 1.287 from these, and then my results should fall in the normal region. Now, if I subtract 1.287 from here, I'm going to end up with a negative number, so it doesn't fall in the region. So this one we're just going to ignore. If I then do smaller one first, so 5.124, if I subtract 1.287, we're going to get 3.84. And if I do 7.442, subtract this, I'm going to end up with 6.16, both to 2 decimal places. Okay, and that's it. We've got our results. Okay, question 8. Losing sheets everywhere. Question 8 is just a manipulating fractions question. So we're going to write this as a single fraction in its simplest form. Then we're going to put -2 on it and simplify it again. And then we're going to differentiate. So first things first, 4x minus 1. So if we're going to write this as a single fraction in its simplest form, I just need the denominators to be the same on both. So this one needs a 2x minus 1. So I've got 4x minus 1 and 2x minus 1. I can then just write the minus and the 3, and both would then be over exactly the same denominators. Okay, so hopefully we're okay that I've done that in one step. All I've done is multiply top and bottom of this one by 2x minus 1. So the bottoms would both be the same. Top of this one would be the 2 brackets. Top of this one is just the 3, and we were subtracting, so I've put a minus. So if I expand it at the top, I get 8x squared. I'd have minus 4x minus 6x altogether, and then plus 1 and minus 3. So I've got 8x squared minus 6x minus 2. So very first thing I'm going to do is I'm going to factorise a 2 out of the top, just because that's going to then be able to simplify with that extra 2 on the bottom. So 2's on the front of both cancel, and then we just need to factorise the top. So I get 4x and x. I want a minus 4 and add 1. X minus 1 cancels on both. I end up with 4x plus 1 over 2x minus 1. Right, next part is we're then going to take the exact same equation, but we're going to put -2 at the end, and we want to show that it can be written like this. So I'm going to take the answer that I got from part A and put -2 after it. So think of this as 2 over 1, and then all you're going to do is give both of them the same denominator. So I've got 4x plus 1 minus 2 lots of, and this one I would be multiplying top and bottom by 2x minus 1, and then both fractions would both have 2x minus 1 on the bottom. So I've got 4x plus 1 minus 4x, and just be careful, you'd then have plus 2. These are going to cancel each other out. I end up with 3 over 2x minus 1, which is what it asked us for. Right, part C to this is that is our f of x function. We want to differentiate and find f dash of 2. So first thing we're going to do is we're going to differentiate that. I'm just going to rewrite it. So differentiating this, you've got something in a division format, so you're using a quotient rule. So u is 3, v is 2x minus 1. If I differentiate 3, I get 0. If I differentiate 2x minus 1, I get 2. Now be very careful, this is the one where we keep getting the formula the wrong way around. So it's v du dx, well that's just going to be 0. minus u dv dx, which is 6 over v squared, so 2x minus 1 all squared. So I've got this as my differentiated function. And then it asks us to find f dash of 2. So you're just going to plug in 2. I get minus 6 over 2 times 2 is 4. Take away 1 is 3. 3 squared is 9. So I end up with minus 2/3 as my answer. Hopefully that one not too bad.